In the previous lecture, I told you about 5 technical risks to the preservation of digital information. As we don't have enough time to cover the mitigation tools to all of these risks, like one tool that would require a separate lecture is metadata, which is a very complicated topic. I will introduce you to the most important tools to mitigate the obsolescence risks. And these tools are also called preservation strategies. First of those strategies is labeled computer museum, which is what it sounds it is. It means basically preserving old computers that were used to create some information, and then all the access to this information whenever it is needed in the future is done using those old computers. So we assume that we are able to preserve the full environment. The reality is that that this computer museum strategy is not sustainable in the very long term. I guess in the best case scenario, physical computing system can survive maybe 20, 30 years of storage, but after that it's pretty much sure that something will break down. Most computers involve moving parts that break down over time. Also because of the laws of physics, like the second law of thermodynamics that states that entropy keeps growing just by itself without any malicious activity from humans needed, or the diffusion of molecules between different substances. This all makes sure that the parts of the computer will break down, and many decades into the future it's very sure that we will not have a way to obtain those spare parts, because the companies have moved on to newer models. So in order to tackle those computer museum issues, there is a smart strategy called emulation. What emulation is, it means creating a software that behaves in a similar way that the original hardware did. So we are able to actually run the old software in our new computers without the old software actually realizing that it is being run in a wrong platform. A good example of this from the entertainment world is the original movie The Matrix, where the humans were living their everyday life and thinking that the world is as it always used to be, while it later turned out that they were actually put to sit in certain baths connected to a big computer system, and the world they thought was real was actually fake. It was projected into their brains. So this was in effect an emulation of the real world inside the human brains. So computer emulation is a very similar thing. The computer software is made to think that it lives in a real world, in a real original hardware environment, while in reality it runs in our present-day modern computers. But there are also shortcomings to this approach. For example, the emulators themselves get outdated as the technology progresses, so we need to program new emulators. Also, using old software through emulators actually means that the user needs to know how to use those old software tools. And this knowledge disappears very fast. Only 20-25 years ago, textual computer interfaces were very common. For example, the MS-DOS operating system, which was based on giving textual commands to the computer. When we think to the present day, where people are used to touchscreen tablet computers, for example, the kids of nowadays, they are totally unfamiliar with those old text interfaces. So when we have preserved some information in the form of emulation, as it requires to use the old software, the present-day users will actually be unable to access the information because they can't even open the files. So to mitigate this problem, there is another strategy called migration, which instead of transforming the underlying platform, transforms the actual data files that we preserve. So we take our old files and we open them in some special software that is able to convert them from the old format to some present-day format. For example, we take very old Microsoft Word doc files and convert them to PDF, which is still widely used today. This seems to solve the shortcomings of Computer Museum and emulation strategy, but like all things in life, it also has its shortcomings. So the problem with migration is that no migration is actually perfect. So we pretty much always lose some aspect of the original data when we migrate it to a newer format. So it's not reasonable and long-term sustainable to keep migrating the records after every few years. How to fix this? There's the fourth strategy called archival formats, which means doing either just one migration, moving the original files to the new archival format, or actually creating the files in archival formats from the very beginning. So whenever possible, this approach is being used by the archives. But again, in many cases, it's not possible because of a variety of reasons. For some types of content, for example, CAD drawings, the drawings of technical designs, designs of houses, designs of physical equipment. These files are not. There is no archival format yet to actually save this type of information, and also in some cases the archival formats are not as capable as the original storage formats. For example, if we have a Microsoft Excel table with formulas in it, and we convert the file to PDF, which is considered to be a good archival format, then we actually lose the dynamics. We lose the formats, the formulas. We actually get only the data, the resulting values that are calculated. So what is being done in real life in the digital preservation world is that all of those strategies are combined, and this way a sustainable solution is found. So to sum up, this was only a very brief introduction to the risks to digital information, and much more must be said and read about it to understand this topic completely. But in short, a digital repository has to evaluate all the risks and assign a probability score and extent score to each risk, and then multiply those two to get the total risk score. And then based on those risk scores, we get a list of risks on the order of importance, and then we should develop a strategy to actually comprehensively tackle all the risks that have a significant risk score.